So the next collision avoid in technique that we are going to see is quadratic probing. It's similar to linear probing, but with one small difference. That is, over here we are going to use the same hash function k mod the table size, and the next function, if collision occurs, we are supposed to use this particular function, but with a difference. The hash k value which you find out by k mod table size will come over here, but plus it was I in linear probing, but now it is I square, mod the table size. So just one difference from linear probing is that instead of I, we are going to use the I square. So it is also used to linearly store data, but it helps us get the value of linear storage more quickly if a collision occurs then. So I's values are rightly mentioned, it is iterative, we start from 0 until and unless we avoid collision, we are going to keep on changing the I values. The data that we require is right here, the keys, the table size is going to be 10, and I have created the array for the same. So here we go. Let's begin by finding our hash values. So the first key is nothing but 3. So let's find the hash function for 3, that is hk. The first hash function is hk k mod 10, because the size of the array, size of the table is nothing but 10. So it is nothing but 3 mod 10. The answer that we get is 3. Is the location 3 available? Yes, it is available. So we can just put our key right there in that particular location. So let's put it. Here was 3 in the table. Next one, the next key that we have is nothing but 5. So let's state 5. And let's first find out its hash. It's 5 mod 10. The answer for the same will be 5. Is 5 available? Yes, 5 is available. So we can store the data right there. So let's store it. We store 5 right there. Now the next one on the list is basically 13. So let's take the key 13. Let's find our hash value. 13 mod 10. The answer that we get is 3. And this is nothing but a collision. So once the collision occurs, we need to apply the next quadratic hash function, which is rightly mentioned over here. So let's note it down. This is going to be a hash function. So what is hk right now? Hk is nothing but 3. So let's state 3. What is the first value of I? It is nothing but, we start always from 0. So we are going to have 0 square mod 10. So 3 plus 0 mod 10. The answer that you all will get again is 3. So again, it's a collision. So this is not acceptable. So the next thing that we do is basically go to the next part. So again, we increment our I. So now previously I was 0. So once we increment it, it will become 1. So here we go. We are going to have again hk is nothing but 3. So 3 plus 1 square mod 10. So 3 plus 1 mod 10, which is nothing but 4 mod 10. The answer for the same is nothing but 4. So is 4 available? Yes, 4 is available. So we can store the data right there. Let's go and store 13 in location number 4. So once we are done with 13. So we go to the next key, which is nothing but right here. Key is 24. So let's apply our hash function, which is nothing but 24 mod 10. The answer that we get is 4, which is nothing but collision, because 4 is already occupied with something else. So we have to again apply the another quadratic hash function. So let's mention the function hi plus I square mod the size of the table, that is nothing but 10. So what is HK? HK's answer that we got was 4. So 4 plus 0 square mod 10. The answer that we'll get is again 4. So this is again collision. This is not acceptable. So we'll increment our I value, that is nothing but, it was 0 previously. So if we increment it, it will become 1. So 4 plus 1 square mod 10. So 4 plus 1 square is 1. So 5 mod 10. The answer that we get is basically 5. So this is also not acceptable because it's a collision. So again we'll have to increment 1. So once we increment 1, we get 4 plus 2 square mod 10. Once we solve that, the answer that we get is 8. Let's check the location number 8. The location number 8 is empty, so no collision. We can add our value right there. So let's insert 24 in 8. So with this, our one more element has been inserted. Now we go to our last and final element, that is nothing but your 33. That is nothing but your 33. So your key is basically now 33. Let's come over here to 33. So let's find a normal hash function 33 mod 10. The answer will be 3. Answer is 3. Is 3 available? No, 3 is not available. So it's again a collision. So this is not going to work. So what do? We apply the next hash function right here, and that is nothing but hik plus I square mod the table size, which is nothing but 10. So what is ht in this case? Ht is nothing but 3 plus 0 mod 10. The answer for that is again 3, which is not acceptable because 3 is already occupied. So the next one, we have to increment I 0. Instead of 0, we'll have 3 plus 1 square. The answer that we get is basically 4. Is 4 available? No, 4 is also not available. So that is not our option. So that is just not our option. Next, we go for incrementing this 1 by 2. So 3 plus 2 square mod 10. So what is 2 square? 2 square is nothing but 2 into 2 will be 4. So 3 plus 4 is nothing but 7. So 7 mod 10. The answer will be 7. Is 7 available? Yes, 7 is available. So we'll put our data right here. So 33 will go in block number 7. So that's how we solve the quadratic probing part. So this is your quadratic probing. Remember, instead of normal I, we are going to use I square. That's the difference from linear probing to quadratic probing.